Okay, we have seen Anna. Fan in the of place. Any doubt with this? Huh? Okay, next. Current sinking and current sourcing. What is sinking? What is sourcing? Source means from one place, when we are giving something, it is source. When we are taking something, it is sinking. If it comes to us, it is sinking. When we give, it is source. Remember that. So current sourcing is, for any circuit, you have a device and a load. Device will drive the load. Device and a load will be. Some electrical circuit is there, these are loads. Fan, light, they are all loads. It will draw current and it will function. So current sourcing means if the current flows out of the device. From me, if I give something, it is sourcing. If I take something, it is sinking. Okay, sourcing is when I give. When I take, it is sinking. That you remember. So current sourcing is when the current flows out of the device. From the device through the load, it goes to the ground. That is source. If the device take the current through the load into the device, it is sinking. Yes or no? Sourcing means giving. Sinking means taking. Okay? So these two definitions. Current sourcing, when the current flows from the power supply. When the current flows from the power supply through the device output, and then to the ground. Power supply, device, that is giving source. Example, the device pushes current out to turn on an LED. Okay, this is your device. You have a power supply. This is taking power from this, and this is making a line to grow. For which what it does? It gives the current. It gives the current, which we call it as source. Current sinking, when the current flows from the power supply through the load and then onto the device. So what is the device allows current to flow through the ground to turn on the LED. So you have a device, you have a power supply, you have the load here. So the power supply comes through this and then to the device. So that is called as sinking. So you can see here, device is here, power supply is here, load is here. The current goes from the power supply through the device to the load, it is called sourcing. The power supply or power supply is connected here also, it comes through the load into the device, it is called as sinking. Okay, you remember this? So this is what is shown here. Power supply to the load, current flows into the device, then to the ground, is called as current sinking. Power supply, current flows into the device, then to the load and to the ground, is called as current source. Okay. Next is speed power product, which is also called as figure of rate. Speed power product. Whenever the device design is there, we have to make sure that your device speed is high and the power consumption is a good reason. Speed should be high and power consumption should be low. So for digital chips, that is ICs, integrated circuits are called as chips. It is important to have fast switching. That means what? Propagation delay should be less. Okay, fast switching, that is shorter delay and low power consumption. But usually increasing speed causes more power to be used and vice versa. That means what? If you want speed, you will have more power. If you want less power, speed will be less. Some trade-off. Trade-off means we have to let go some certain things to achieve certain things. Suppose you want to study, tomorrow you have internal exam. What you will let go? Your sleep. I want to sleep as well as I want to study well. So some trade-offs. You need to know which one is priority. Sleeping is priority or getting good marks is priority. So here also in the design, they will be checking whether speed is important or power consumption is important. No, I want this very fast. The person who is buying, the customer, doesn't bother about the power consumption, but he wanted a faster computer. Then design like that. No, should not consume more power. Even if it is slow, it is okay. Some people will say that. So, if you want the product to be normal, what you should expect the normal speed, the normal power consumption. Moderate. Then only you will get both. So, the speed power product, that is speed into power. Speed and power combination product is a way to measure and compare the chips by multiplying speed by power dissipation. A smaller SAP means better overall performance. Smaller means speed into power. This product should be as small as possible. As small as possible. Then we can say the performance is good. So this is a very, very important term. They may ask you about figure of merit or speed power product. Understood? This is explained here. So digital ICs need fast switching. That means no delay and low power consumption. Both are expected. Trade-off. If you want more speed, what happens? More power consumption will be there. If you want less speed, less power consumption, less speed will be. So speed power product is the delay into the power used to compare the logic families. Which family is good? Which family will give me lower speed power product? That we have to check. So lower speed power product will give you better performance. So this is what is measured in picojoules, PJ. The unit is picojoules. Okay. Now we have completed, and again once again I will revise you this logic families. We started with logic families. So before that we saw what is a logic gate. Logic gate is the basic building block of any digital circuit. It operates, it performs the Boolean functions like AND, OR, NOT, exclusive or exclusive. All these operations are done by the logic gate. Logic family uses the logic gates to build the digital circuit. Different logic families will be there. Each family will have a different characteristics, different voltage levels. So logic families we have different examples: TTL logic, CMOS logic, ECL logic, then RTL, DTL logic. These are all different families. So we have some advantages of these logic families: compact sizes, small, low cost, reliability, high speed, less wire. So these are all some of the advantages of using integrated circuits. Then characteristics of logic family. This is very, very important. This is a sure question for you. So propagation delay. Propagation delay is what? How much time the output takes to respond to the change in the input. If the input changes from 0 to 1, if it is an inverter, how long it takes for the output to go from 1 to 0? Are you able to understand? This is your input. Not or inverter. So this is your input. So when this changes, what happens? Your output will change like this. That means a small delay. This is called as. What is this in terms of TP, HL, LH? What is it? What is the delay? TP? TP? What is it? HL or LH? It goes from high to low. HL. If it goes from low to high, then H, otherwise HL. Then noise margin is what? Definitely every electrical signal will have some noise induced. How much you can tolerate? How much you can tolerate? So that level is called as noise margin. And then fan out, fan in. Fan in. Fan in is what? How many inputs you can connect at the input of a gate? And fan out, how many outputs can be connected? How many outputs can be connected is fan out. How many inputs can be connected is fan in. And then operating voltage. At what voltage high level is operated, low level is operated. Speed, the switching time. Going from 0 to 1 or 1 to 0 is switching time. Then input output current. How much current is required to drive the inputs and outputs. Then logic levels, high and low. What is the logic level of your family? Some will be 0 to 5, some will be 0 to 3, some will be 0 to 15, some will be in ECL is in negative voltage. So this low and high will differ from family to family. Then compatibility. How one gate can be compatible with one family to other family. Okay. Then cost and availability. How much cost will this particular logic gate will be, or if this family will be, whether it will be available easily or not. Suppose I am developing a circuit and suddenly it is not working, I want to gate this. Whether it will be available in the market or not. How will be the cost? So those things are the characteristics of logic families. So this is the comparison between the CMOS and TTL. So mainly you want to remember speed, power, voltage. Logic families define performance of logic gates and digital circuits, and mainly they differ with the speed, power, and the voltage. Voltage levels of high and low, how much speed it will be, or how much power it will consume. These are the three very important. If you remember these three words, that's all. Write and underline. About logic families, difference will be in these three only: speed, power, and voltage. Then classification. So initially it is classified based on whether the current flow is in one direction or two directions. Bipolar, you have the current flow in two directions. In unipolar, the current flow will be in single direction. In bipolar, we have two. One is saturated, another one is unsaturated. Because for every transistor, it goes to cutoff region, cutoff, active, and saturation. This is cutoff and active. It will not go to saturation. Based on that, they are divided. So in saturated, we have RTL, DTL, DCTL, I2, and HDL, and DTL. And in this syllabus, we are going to talk about TTL, RTL, DTL. Schottky as well as the limited coupled logic, and unipolar only single direction current flow. We have PMOS, mass devices will be there, metal oxide semiconductor, P channel, N channel, and CMOS. CMOS is complementary metal oxide semiconductor, where you have P channel as well as N channel. So this is also very, very important. Very, very important university question. Yes, this diagram we have to remember. So these are all what we discussed. So logic families, also isolated logic families, unipolar, everything is over. Now characteristics also we have seen: propagation delay, PPH, LPP, LNH. An example of lithium card. So propagation delay, these are the things. When the propagation delay goes from low to high, it is PPLH. And when it goes from high to low, it is PPH. This is what is the diagram you have to remember. So it is measured from the middle to middle, not from middle to end. So that diagram you have to practice, and this is also a very important university question. Surely there was. Okay? So this is another thing. This is one example. You can write some example when it changes, how much delay it causes the output to change. So that example you can write. Okay, next we came to noise margin. Noise margin is from outside. These are the two devices. This is giving to the. This is output. This is input of the device. So here. In the high level is 5 volt, when it is giving it is 5 volt, but when it is entering here, it becomes 4.5. So how much band is allowed? So in the input device, if it is 4.3 volt is also considered as high, then this will be considered as high. Okay? Then coming to low side. In the low side, this is the output of a device, this is the input of a device, and here I am connecting. I am sending the low signal. Low signal is actually 0 volt. But due to noise, what happens? 0 volt added with some 1 volt. So it is going as 1 volt. And this device has a noise margin such that it can accept 0 to 1.5 as low. At that time, what happens? This volt, 1 volt is coming between 0 and 1.5, so this will be considered as. So that margin is called as noise margin. Here. So here this is the output characteristics. So this is 5 volt, this is 4.2 volts. 4.2 to 5 volt, this particular device says it is high. If it is 4.1 also, it is not high. That voltage is sent to the other device. While sending it is sending as 5 volt only. But when it is going, what happens? Adds noise. So 5 volt minus some 1 volt. This is a noise. So here it is coming as 4 volt. And the noise margin is 5 volt to 3.9. So what is the noise margin? From 3.9 to 5 volt, this device will recognize as a high voltage only. The coming voltage is 4 volt, which is between 3.9 and 5 volt. So that will be recognized as high voltage only. Suppose this becomes 2 volts. How much I will get? 3 volt. So this will not be recognized as high voltage because it is not within that band. So that band is what we call it as a noise margin. Then fan in chamber. How many devices you are connecting to the output is called as fan out, and how many devices you are connecting to the input is called fan. because it has to supply current. If you have 10 amps, if every device requires 2 amps, it can take one more because 10 amps can be supplied to 5 devices as 2 amps, 2 amps, 2 amps, 2 amps. Suppose you have one more, does this device, it cannot supply because it does not have it. So that will become loading. Extra current it will try to draw, but it doesn't have it. So only 5 maximum it can have. So the fan out of this particular device is what? 5. Only it can supply current to 5 devices. So that is fan out. And fan in, how many inputs can be connected? Then currents will be current source. If the current flows through the device to the outside, it is source. If the current goes from the load to the device, it is single. Clear? So all these questions will come. Then speed, power, product. The product of the speed and power as low as possible should be achieved. But you will have trade-off. Suppose you have more speed, if you want high speed, power consumption may be high. If you want less power consumption, speed also will be less. So you have to decide which logic family can be used. So next, as we have seen some families in the classification, resistor, transistor, RTL. This is again 8 marks, 10 marks, anywhere they pass. So resistor, transistor logic. What is resistor, transistor logic? This is the earliest ways. These are all used long back in the digital logic circuits. They use resistors and transistors in the circuit. What is the function of resistor? Resistor will limit the flow of electricity until set the states for 1 and 0. Resistor will limit or stop the flow of electricity depending on the resistance value. The resistance is low, it will allow easily the current to. Then transistors. Transistors act as a switch on, off. So it acts as a switch. When turned on, they connect parts of the circuit. When turned off, they disconnect. That means when we are turned on, they connect. When they are turned off, this is closed, this is open. Right? Transistor is a switch. It will turn on, off. Now we are going to see RTL NOR gate. What is NOR gate? If you have A, B, R, NOR. So no inputs, you have 0, 0, 0, 1, 1, 0, 1. What is the output here? 0, 1, 1, 1. Right? NOR is 1, 0, 0. This is what we are going to construct using the resistor transistor. So if both A and B are 0, what happens? The transistor stays off and the output is 1. If either A and B are 1, then the transistors are on and output is going to be 0. This is what is the logic we are going to use. Output is 1 only if all the inputs are 0. Only when all the inputs are 0, output is 1. If any of these inputs are 1, then what happens to the output? Outputs are 0. This is what is normal. So that we have to implement this. So real life example, think of a lamp connected to a switch. If the switch is off, the lamp is The switch is off, the lamp is on, like the transistor being off, the output is on. You have to imagine that. When the transistor is not conducting, it is not connected to ground. That means the VCC will appear at the output. That means output is high. The transistor is not conducting. The transistor is not conducting. What is this transistor? The symbol tells you what is this type of transistor I will show you. Type of transistor, PNP or NP? Completed EDC right? Always remember the arrow will be from to N. Very easy to remember. Always the arrow will be from positive to negative. High to low. Okay, remember like that. So whenever you get a symbol like this, what is this transistor? Mark from where the arrow starts, mark the speed. Then remaining PNP, NPN comes based on the arrow from where it starts. Now it will be easy for you to. Now tell me what transistor is it? It starts from here, the arrow mark starts from here. Is it this? T. So N on the other side. Suppose your arrow mark is here. So first you should mark your P. Then V. So don't worry. Always positive to negative will be the flow of current. Positive to negative. Positive is actually high and negative is actually low. Always there will flow from high to low. You have a mountain. Water falls here. Water flow from high to low. Remember. High to low. Positive to negative. From where the arrow starts, mark P first. Then the remaining terminals is the is very, very important. So here we are going to use an NPN transistor and suppose if the transistor is like this. Okay, the transistor is switch is off, that means this is not conducting. So, it will be like an open circuit. So, what will come here output? VCC will come as output. So, if the transistor is not conducting, the output is going to be high. Something like this. And if the switch is on, the lamp turns off. Because the transistor is on and the output is 0. When the transistor is on, what happens? It will be like a short circuit. So when the transistor is on, what is on? This is conducting. So what will be the output? 0. Connected to short circuit to ground. So that is what we are going to use here. RTL uses only resistors and transistors. RTL uses only resistors and transistors and no other components. The name itself says resistor, transistor, logic. Then the most common logic gate, they will ask what will they ask? NOR gate. That's why I say 50 unit, everything is expected. Nothing new. These things if you study easy. Then the output is high only when all the inputs are low. That is because of the table. And when any input is high, the output is low. Simple construction here. So whatever I told here, let us see here. Suppose I am giving what is the name here? A, B, or none. This is what we want. So first case, we will take 0, 0. Two transistors are there. Two are empty. Why we need to know what it is empty and all? Depends upon the voltage applied to the base. Decide whether the transistor is forward biased or reverse biased. So for P, which is a positive terminal, I am giving a low signal. It's a reverse bias. What happens to your transistor that whether it will be on or off? 0 is given here. 0 is given here. So that will turn off the transistors. It will not contain. So how it will go? Take to open circuit circuit. When the transistor is not conducting, it is open circuit only. There is no current flow. So what will be the output? Output I am taking here. What will I get? I will get the pi value here. Pi will be equal to 1 or I. So in the first condition, what happens here? 0, 0. Not get output is equal to 1. Clear? So now coming to 0, 1. What will happen? Any one transistor will turn on. This will not turn on. This will not turn on. This will turn on. So how will be your circuit? What will I get at ground? 0. It is directly connected to ground. Then are you using 1, 0. So now which transistor will be on? This will be on. This will be on. Right? So here, so when you take an output, this becomes 0 because it is directly shorted to ground. And next condition is what? 1, 1. You all know the transistor operation or not? You are all saying like that about it. When it is forward bias, it is conducted. When it is reverse bias, it is not conducted. So here high, this is conducting. This is connected. So what will happen to the circuit? Output will be what? Directly it is, with both the sides it is grounded. So the output will be 1. So this is what is the NOT gate. Only when both the inputs are 0, the output is 1. In all other cases, it is 0. This you have to draw the circuit and explain. So you can also use this. Next, repeatedly asked question is, in all the university question paper, whichever question paper you take from 10 years, short transistor, MOSFET. Okay, so very important question. This is what is the subject. Calling happening. Transistor, logic. You have 4 transistors. 4 transistors. So NAND gate, what is the truth table? So what is 0 and 0? And what about NAND gate? This is what we should take. When both the inputs are 1, the output should be 0. And all other cases it should be 1. Okay. Now you start giving the input. Suppose I give 0, 0. What level? What is this transistor? Correct? All are empty transistors. So we have 4 transistors. Q1, Q2, Q3, we have 4 transistors. So when this is 0, what will happen? This is high, this is 0. That means it will be power loss. Right? Q1 is on. Then what happens? Q1 is on. What about the other one? What happens to the other transistors? Q2, Q3, Q4, how they will function? Zero, zero. A equal to 0, B equal to 0. Here we go and get B. Okay. So when both the inputs are low, both the diodes are converters. Here we are assuming one junction as a diode. Your textbook, they would have given you a diode diagram. So the current due to supply voltage will go to the ground through R1 and 2 diodes will be here. So here the diodes are, I don't know whether it is there. I take my example.